The biggest challenge in that regards is the exponential growth of data. It's predicted that by 2020, medical data doubles every 73 days. And if you look into radiology in particular, then we see an increase of CT and MR examinations by 10 to 12%. And at the same time, the increase of radiologists is around 3 to 4%. So this clearly shows a gap that is created here. And ultimately, this leads to an interpretation time of 3 to 4 seconds per image. Other studies also show that if you halven the interpretation time for radiologists, then the interpretation error rate increases by 16.6 percentage points. So all in all, it's a balance between volume and the exponential data that we see, on the other hand, also compared with the diagnostic accuracy. Machine learning is a subcategory of artificial intelligence and divided into two tactics. Traditional machine learning, which is based on handcrafted algorithms looking for specific features, and deep machine learning, which is based on neural nets that have multiple hidden layers in between the input and the output channel. Traditional machine learning algorithms at some point stagnate with the increasing amount of data in terms of the performance. And deep learning approaches that came up around 2011, 2012 have the ability to outperform this one and gaining accuracies up to 100%. This is why deep learning is so interesting to solve clinical questions, and there's a lot of potential into it, beside the downsides that you need to have a lot of curated and annotated data to train it, a supercomputing infrastructure to perform this training, and also experience in how to model those algorithms. In medical imaging, several AI-powered applications are currently already running in the background, like silently. So we use this technology already in our devices to accurately acquire medical images, to accurately acquire data, decide on the best positioning for the patient, on the best scan range for the patient, to do a first-time right approach while acquiring medical data. On the other hand, if you step up this ladder into the medical image data interpretation, then it goes into assistant systems. So we call this so-called companions that augment the work of the radiologist in medical image interpretation by already deriving pre-analyzed information with visual annotations, with quantification informations that were immediately being driven into the reading front end of the radiologist to assist him in his daily routine. Applying artificial intelligence has basically three dimensions: the productivity and efficiency aspect, so transforming care delivery by optimizing workflows, expanding precision medicine by reducing unwarranted variations and improving diagnostic accuracy. And both of this has an influence on the patient experience, where we could, with the help of AI, sort work lists or avoid unnecessary interventions. Summarizing this one, what's important for the clinical routine is that it immediately comes into the radiologist's workflow. So everywhere where he's using this solution, it should be already available, like in the PACS front end or in the viewing front end. It should be a scalable solution, for example, a cloud solution, to be flexible in the digital age to update the algorithms. And in the end, it is also a solution that should not solve a single task. So it should be a systematic approach, like a multi-organ interpretation at itself. So industry and the appliance of AI is a team effort together with legal and regulatory authorities, and most important for sure also with clinical collaborations. So it's only possible to train algorithms in those clinical collaborations, so it's a team effort to do so and to bring this into the acceptance of the ones that are also using it. Medical specialists should look at AI not as a technology to compete against. It should be a very valuable asset in their toolbox to use to solve clinical questions. This is something where already intelligence officers predict that we will see more diagnosticians in the future now that will solve more complicated questions or challenges, and the routine task will be fulfilled with the help of artificial intelligence. In applying data scientists' concepts and tactics, we might potentially see in the future new roles like clinical data scientists that could help also bring the knowledge on how to aggregate data, how to analyze data into the clinical problem solving, and this is what is of utmost importance.